Please let me know if you are not understanding any of the steps. See, these derivations are important because they tell you how to maneuver a particular question. Although derivations will not be asked anywhere, but still you should know how we are getting K. What is K? K is basically KF by KB. Small stuff like that. Let me know when you have written.
Sir, done.
Okay.
Done, sir.
All right. Daksh, have you done? All right. Let's move ahead. Now see, you have obtained this equation. Just a moment. Yes, you have obtained this equation by dividing 1 and 2. K is equal to AF by AB e to the power minus delta H by RT. You have obtained this. Now what we are going to do is we are taking log on both sides. When we take log on both sides, we get ln K ln AF by AB minus delta H by RT. Now one more thing. We don't like ln very much. Why? Because the calculation in ln is difficult. We do not know how to do or the values of ln. So we prefer to do it in log. Log is to the base 10. ln is a natural log. Difference between ln and log What is it? ln is natural log, while log is to the base 10. ln is a log to the base e, that is natural log. Log is always to the base 10. Okay. Now, there is a conversion factor. ln x is equal to 2.303x. In case you didn't knew it, I mentioned it down. Now we are going to convert all ln used into log. Okay, so what we did was ln by 2.303. We divided all ln's by 2.303 and hence obtained the equation in log. And now the equation which we have obtained is log k is equal to log af by ab minus delta h by 2.303 RT. Now this is also a very famous equation, although not as famous as which we are going to derive after it. Okay. Now by this particular relation, which is written in the box in front of you, we will derive a very famous equation known as Van 't Hoff's equation. Okay. So before doing that, just complete these 3 or 4 lines derivation more. Then we'll move to Van 't Hoff equation. Derivation of the Van 't Hoff equation from this particular equation. Just please write these 4 lines. Starting from k is equal to af by ab e to the power minus delta h by rt, then ln k, and then finally the expression in log k. Daksh, what is going on in your school?
Sir, they have completed class 11.
Acha, have they started class 12?
Yes, a little bit.
Acha, so what topics are they doing in class 12? Daksh school is best. They have completed class 11th. Whole of class 11th. Niranjan, what about you? What is going on in your school?
So they are teaching like the preparation of washing soda and other things, the sodium-based compounds.
Okay, so that is S block.
Yes, sir, S block.
Okay, okay. So they have completed equilibrium and all, and then they have went to S block, right?
Yes, sir.
Okay, okay. And when are they planning to teach organic?
So um, they haven't given the syllabus for the next
Okay,
week.
okay, okay. All right, all right. Let me know when you have written this.
So done.
Okay, okay.
Sir, can you hear me?
Yes,
Done,
Daksh,
sir.
I can hear you now.
Sir, they had started solid state.
Oh my God, my God. What are they trying to do and what are they trying to teach? I mean, that's horrible. How can you retain so much of the things? Even 11th class is pretty difficult, not that easy when you study it to the competitive level, and they have started 12th. All right, all right. I think you will forget many things now, Daksh, because they
I
are.
don't attend the class only of school chemistry.
You don't attend the class. That's a very good solution. All right. Moving ahead. Yes. Now, what we are going to do, we are going to derive very famous Van Hoff equation. And let me show you what the Van Hoff equation looks like. This is the Van Hoff equation. This is the thing which we are going to derive finally. And this equation, as you can see, is showing the dependence upon temperature with the equilibrium constants at two different temperatures it is showing. And then there is also delta H. Okay, this is a very, very famous equation, let me tell you, in chemistry. Now we are going to derive this. Very simple, not a big issue. Now please see. At first we say let at T1 temperature K1 is equilibrium constant. Now we have changed the temperature to T2. Obviously, the equilibrium constant will also change to K2. We substitute K1, T1 in this equation, getting the first equation, then K2, T2 accordingly, getting the second equation. Now what we are going to do is subtracting 1 from 2. So from this equation, second equation, we subtract the first equation, 2 minus 1. So what we are getting is log K2 minus log K1. Then I have taken this thing common outside because this is common in both equations. That is minus delta H divided by 2.303 R. What is left is 1 by T2 minus 1 by T1. Okay. And I think this is the final derivation of the equation. Just copy this. Then we'll do some questions. Please copy the derivation of Van Hoff equation.
Sir, done.
Okay. Yes, is the group bit done? Daksh, done? Charan?
Done, sir.
So done.
All right, let's move ahead. Now, let's do some questions on it. Okay, the question is on increasing temperature try this. Easy question. Only apply the formula. Answer will be there. Yes, please use the vant hoff equation. You can use the calculators if you wish. I think you can do this very easily by this. Log K2 by K1 is equal to, what is the formula? Please tell me. Log K2 by K1 is equal to, yes,
delta H by 2.303 R into T2 minus T1 divided by T1
T1,
into
T2.
T.
Yes, that is correct. So it is saying on increasing the temperature from 27 to 227, equilibrium constant gets double. So calculate delta H. Yes. So it would be log 2 is equal to delta H divided by 2.303. And the value of R here, you can, if you are going to take the R in 8.314 joules, the answer would come in joules. Otherwise, it would come in liter ATM. Okay, so you can take 8.314 here. And T2 minus T1, these temperatures are given to you. So T2 minus T1 would be 200 divided by
200.
T1, T2. Yeah. And T1, T2 would be 27 into 227. No, no, no. You have to write the temperatures in kelvins and never in degree Celsius. Okay. So calculate T1 now properly. 27 plus 273, which is 300. T2 is equal to 227 plus, sorry, 273.
Fine.
This will be 500. So it would, I'm sorry. So it would be 300 into 500. Whatever the answer is, the delta H is this. Okay. Very, very simple question. Let's try some more questions. I hope you have got that. I hope there is no problem in that question. Easy question.
Yes, sir.
Yes. Okay, great. See, this vant hoff equation, the questions are not very difficult in chemical equilibrium chapter, but in other chapters, along with this equation, like thermodynamics, along with this equation and others combining also, it can be a very, very good question. Okay, but not in chemical equilibrium, not very, very tough questions from this equation. Okay, let's try to do some other questions. And let me tell you, in chemical equilibrium, the first part you can say of chemical equilibrium is over, which was the bigger chunk. The thing which is left is theory based questions, some of the very good theory based questions dealing with the Lee Chatelier. Okay, that is the second part, basically. That is purely theory, and although very, very reason based theory. But we are going to start Lee Chatelier in the next class. So let's try some questions which we have studied, and let's see how good our knowledge has become of chemical equilibrium. Uh, let's try the 60th question. Please see this 6060. Niranjan, can you read the question?
AB dissociates as 2AB in gaseous state gives 2A plus B2. When the initial pressure of AB is 500 millimeter, the total pressure becomes 625 millimeter when the equilibrium is attained. Calculate Kp for the reaction, assuming volume remains constant.
Okay, seems a easy question. Please try. Yes, Charu, can you do this question? Nikhil, what about you?
Sir, doing.
Okay. Daksh, getting this question?
Sir, I'm getting option 2.
Okay. Anybody else? Come on, anyone? Niranjan, Charan, Daksh. Now only the KP is required. KP can be calculated very easily, isn't it? So KP would be KP to the power whole square P divided by 500 minus 2P whole square. That's it. And it comes out to be 2P is 125 into 2, that is 250 square, into P is 125 divided by 500 minus 2P. 500 minus 250 is 250. 250 square. So answer is 125. Yes, please. Is it all right? Come on.
Yes, sir.
Charan, Daksh. So who could calculate this answer apart from Nikhil? Please tell me. Come on. Be honest. Be honest. Please tell me. Who could calculate this answer 125? Except Nikhil. Nikhil has calculated that, I know. Come on. Niranjan, were you able to calculate it?
Sir, I only got like P equal to 125 millimeter Hg. I made a mistake in that 2P square. I didn't take P square. I
Okay.
took only 2P. So
All right. Okay. Charan, please tell. Where were you? Charan. Charan, not able to hear you, child. Can you hear me? Daksh, what about you? Could you solve this question, Daksh? Where were you stuck? Please tell me. I think there are some network issues. All right, then let's move to the next question. This question was fairly easy. Okay, let's try one more. 59th. Nikhil, can you read the question?
Yes, sir.
Mhm.
1.5 mole of each hydrogen and iodine were placed in a sealed 10-liter container maintained at 717 Kelvin. At equilibrium, 1.5 mole each of hydrogen and iodine were left behind. The equilibrium constant Kc for the reaction, H2 plus I2 gives 2Hi at 717 Ks.
Okay. Do as fast as you can.
Sir, I got.
Okay. Answer is?
Sir, I got option 2, 0.16.
Okay. So please explain us, how did you do it?
Sir, we write the reaction first, the balanced reaction, and then we write the initial equilibrium, and then so, should
Okay,
I tell?
let me write it. Okay, yeah, please tell, go ahead.
So 1.5, 1.5 and 0. Then
Okay.
that becomes, we know that it becomes 1.25, 1.25 and 0.5.
1.25, 1.25 and 0.5.
5.
That's what you are saying? Okay.
Yes.
And that's
We
it,
can
Kc.
calculate x from this. Yes.
Only Kc is required. Kc would be 0.5 whole square divided by 1.25 whole square. All right. And that would be 0.5 divided by 1.25. Yes. Go ahead, please tell.
Sir, actually,
1 by 5.
1 minute. So we should get concentration of Hi. So it will be 0.5 by 10 moles per liter. So it will be 0.05.
Yes, sir, it'll be 0.05.
We have to take
Yes.
concentrations of both. So for
Yes.
so even
True.
the denominator will be 0.125 whole square.
Yes. But you will observe one similar
that
one
way,
thing. Yes, pardon?
so that way we'll get the answer as 0.16.
Yes. Let's rejoin. It's less than 1 minute left. Let's rejoin.